Welcome to another episode of Hardware Lens. Today's video is going to be a follow-up to the Intel 10900K direct die cooling video that we made recently. If you watched the last video, we took off the IHS from the CPU and we used the Rocket Cool direct die mounting plate, and then we did some testing with the CPU, thermal testing, and we had some issues mounting the water block to the CPU without the IHS, because when you take the IHS off, you have the water block needs to be able to sit lower to make contact with the die, since the IHS has a thickness to it. And the kit that we had and the water block that we had didn't come with the right size standoffs or enough variety of standoffs to make it work. So we made something work temporarily, but the results weren't all that impressive, or not as impressive as they could have been. So I'm making an update to this video because I found some standoff kits on Amazon and some screws and spacers that I think might help you. If you're using the Arctic cooling liquid freezer like I am, you can use the recommendations in this video. If not, you can probably find the correct size standoff in the assortment that we have linked in the description below. So in this case, we're using the M3 10mm standoffs, as well as two of the plastic spacers, and that gives us the perfect height above the die, so that we have just enough room where we can tighten down the water block and make perfect contact with the CPU die. So if you're using a different water block, you can probably find a combination of standoffs and spacers to make it work. Just use a little bit of trial and error, and if you're seeing a large variance between the different CPU cores, then you probably just don't have good enough contact with the die. And make sure you're careful applying pressure with the water block, but you don't have to worry too much, because the direct die plate should prevent you from applying too much force and cracking the die itself. But please be careful. Okay, so after doing that, did make one more change, and that was the addition of liquid metal. So we used Thermal Grizzly's Conductonaut liquid metal compound that we also have linked in the description below. And this is actual liquid metal, so the heat transfer is much better compared to the Cryonaut paste that we were using before. But it is conductive, so it's a little bit more dangerous, because if any of that gets on your motherboard or on any of the pins or anything like that, it can short out electronic components. So be very careful when using it. Don't allow it to drip. And it's also much more difficult to get an even application with the water block on. I probably had to reapply this thermal compound maybe 5 times before I was satisfied with the temps. I was seeing a huge variance between different temperatures, between the different cores. Core 3 and 6 running much hotter than the other cores, about 10 degrees hotter. And what was happening was, as soon as the water block was put down, if it was moved ever so slightly, that would cause the liquid metal to bubble up, and there'd be a small gap where it wouldn't make perfect contact with the die anymore, and that would lead to some of those cores running much hotter than the others. So that's just a little bit of advice. If you are going to try the liquid metal, make sure you do not move that water block. Once you get it in place, you have to really try very hard to hold it there while you screw it in. Alright, so that being said, let's get into some thermal testing, and we'll run another quick 2-minute benchmark on Prime 95 with the liquid metal and the new mounting, and we'll see what the difference is. So we're going to do two benchmarks. We're going to do one without AVX and one with AVX. So if you remember from the previous video, we were not able to use AVX in any case because the CPU would throttle with AVX, and that was with direct eye and with the heat spreader. So we would throttle at 101 degrees with the heat spreader, and without the heat spreader, just direct eye cooling, we reached 94 degree average after 2 minutes of prime without AVX. And just for reference, the CPU is running at 5.2 gigahertz all core, and we've got 1.38 volts measured at this dye sense voltage. So, alright, let's get back into our testing. So let me pull up prime here. Okay, so I'm going to clear our sensor, and then I'm going to start prime. Well, let me turn AVX off. Let me clear it one more time here. Okay, so there it goes. It's running, and let's see what we get in terms of averages. And just for convenience of measurement's sake, I'm going to use, and I've been using CPU package temp average as a good measure, and you can see the individual cores here, which is a much more accurate measurement if you want it. You can see that here. So it's already running cooler. It's about 10 degrees cooler right now than it was with the Conductonaut direct eye, the way we had mounted it before. So definitely seeing some improvements. Okay, so we'll just let this run a little more here for 2 minutes. Okay, so there's 2 minutes. As you can see here, the average CPU package temperature, well, it's 81 now, but it was at 80 before the 2 minute mark. So that's great. That's a 14 degree drop in average CPU temperature from using liquid metal and reapplying the water block with the offsets. So I think I'm going to leave the liquid metal on this system. There are some rumors out there that liquid metal needs to be replaced every few months because it degrades, but I don't think that's true. As long as you're using a copper water block and you're not using any aluminum, I think the liquid metal will be fine. There's been some videos out there from Gamers Nexus, I believe, that they've had liquid metal, and they've shown that it's thermally stable for at least a year or more under use. So that's good news, and we'll leave that. The next thing now, we'll run one more test because this is without AVX. So we're going to run this again, and this time we're going to use AVX, and we'll compare because if you remember, we have not been able to use AVX at all before we did this. So let's go ahead and run it. Okay, so there's the 2 minute mark and 91 degrees average. So we'll go ahead and turn off prime here. Alright, so with the liquid metal, AVX instructions enabled, prime 95, we have a 90 degree average, 91 degree average temperature. So the interesting thing about that is it's still lower than direct eye with the Conductonaut and without AVX, and it's much lower than with the heat spreader without AVX. So this was a pretty good mod. It enables us to sustain this overclock even with AVX instructions without throttling and without getting the temps too high. So it's a pretty good result at the end of it. Maybe even some more overclocking headroom, especially with if you're not running heavy AVX workloads. With an 80 degree average temperature, we can probably get away with a little bit more of an overclock out of this chip. We have a little bit of thermal headroom to increase the voltage and maybe try for 5.3 gigahertz. So if you enjoyed this video, please let us know in the comments, like, and subscribe to our channel for more. And everything we've used here is linked in the description, so check that out if you're going to attempt this mod yourself.